Hi, all. This is the lesson for algebraic composition. So we are thinking about how we can compose things together. If you remember from last week, that means we're taking one thing and substituting it into another function. And last week, we were working with numbers. Today, we're going to work with numbers and also with whole functions. So if you remember from last week, this function here is read g of h of 4. Right? So we don't want to say the word parenthesis out loud. We read g of h of 4. And what we're going to do is we're going to substitute 4 into the h function. So we're going to start with the inside here, substitute 4 into the h function, and then we're going to calculate that. And whatever we get, the result, we're going to take the result and substitute it into the g function. So I'm going to start with the h function here. So since the h function says 3/2 x minus 2, that's my h function. And then wherever I see x, I'm going to plug in 4. So I'd have 3/2 times 4 minus 2. You'll know that when we multiply fractions, we would have to have two fractions. So I'm going to put it over 1 to make my fractions easier. So 3 times 4 would be 12 over 2. 12 over 2 would be 6, right? This is roughly the same, or exactly the same as if 3/2 is like 1.5 times 4, that would be 6 as well. So you can sort of see two ways to go about getting 6 there. We're going to bring down that -2. So we have 6 minus 2 would be 4. So h of 4 simplifies into 4. So now, since h of 4, the entirety of h of 4 has turned into the number 4, now we're going to substitute 4 into the g equation. So we're going to do something very similar. We're going to write down the g equation, which is 1 minus 2x. And then we're going to plug the 4 anywhere that we see x. So we'd have 1 minus 2 times 4. 2 times 4 would be 8. So 1 minus 8 would be -7. 7 like that. So go ahead and pause the video and try this next one. You're going to follow the exact same method, f of k of -2. Go ahead and pause the video. All right. So I'm going to start with my k function, which is 2x plus 1. And I am substituting in -2. So I'd have 2 times -2 plus 1. So 2 times -2 would be -4, plus 1 would be -3. So I have -3 is my answer. And now I need to do f of -3. So I'm going to look for the f equation over here, 2x squared minus 3x plus 2. So 2x squared minus 3x plus 2. And here, since I see that there is an x in two different places, I'm going to put the -3 in both of those places, right? So I would have 2 times -3 squared minus 3 times -3 plus 2. I'm going to go about simplifying, doing my most powerful things first. So -3 squared would make 9. This times 2 would be 18. The next term is -3 times -3, which would be +9. And I'm going to add 2. 18 plus 9 is 27, plus 2 would be 29. Go ahead and double check your work, what you did on your paper, see if it's the same thing as mine. So this is numerical composition, right? We're taking a number, right? Numerical. We're going to take that number, we put it into a function, and we compose it. Next, we're going to do algebraic composition, which is where we take a function and we put that entire function into another function. So we see that it looks here, g of h of x. So we're going to take the entire h of x function and plug it into the g of x. So we have g of, technically, find out what h of x is. H of x is 3/2 x minus 2. So I'm going to have 3/2 x minus 2. So I'm going to take 3 halves x minus 2, and I'm going to substitute that into the g function. So we'll find the g function here is 1 minus 2x. So I have 1 minus 2x, and anywhere I see x, I'm going to plug in 3x minus 2. So really, it's going to be like 1 minus 2 times 3 halves x minus 2. I'm going to go ahead and distribute to simplify. So negative 2 times 3 halves would be negative 6 over 2, which would be 3, negative 3x. Some of you I know are in the habit of like canceling like this, so you get 3x. The way that I did it in my head was 2 times 3 over 2 would be 6 over 2, which is 3. So bringing in that negative, since it is negative 2 that we're distributing, and then negative 2 times negative 2 would be positive 4, like that. Don't forget to bring down that 1. Combine like terms, you get 5 minus 3x. You could write it like this. That's an appropriate way to write it. Or you could write negative 3x plus 5. It's really your mathematician preference, whichever you like to do first. This is technically standard form because we want the x value, or the x variable term, to go first. Right? Awesome. Go ahead and try to work with f of k of x on your own. Pause the video here. Pause, really pause it. Pause it and try it. Okay. Hopefully you're back. You've done f of k of x, not times. So I'm going to take k of x. I'm taking k of x and plugging it into the f function. So the f function is 2x squared minus 3x plus 2. And I'm going to take the k function and plug it in both of those x places. So since there are 2 places where there is x, I'm going to plug it in twice. And what I'm plugging in is that 2x plus 1. So I'm plugging in, this is 2x plus 1. Plus, make sure, yes it is. All right, so I'm going to have 2 parentheses squared, so that's my x squared, minus 3x plus 2. And then I'm going to go ahead and plug in 2x minus 1, or 2x plus 1 in this place. So 2x plus 1, 2x plus 1. I'm taking k and I'm substituting it into the f function. I'm going to go ahead and do my square first. For some of us, we might think like, oh, I want to distribute in the 2 first. So I'm going to say, oh, pause. Multiplying in the 2, distributing in the 2 would be multiplication. But I also have an exponent here. So in the order of operations, PEMDAS, remember that exponents come before multiplication. I'm going to do the exponent first. This means 2x plus 1 times 2x plus 1, right? For many of us, we use box method for this. So I have 2x plus 1 times 2x plus 1. That'll be 4x squared, 2x, 2x, and 1. So for this section here, I would have 4x squared. I'm combining 2x and 2x will make positive 4x plus 1 here. I'm going to go ahead and bring down the 2, the negative 3 times 2x plus 1, and the positive 2. That purple section is now there. And now I'm going to go ahead and distribute in the 2 into each of these, and then negative 3 into each of those. So 8x squared plus 8x plus 2 minus 6x minus 3 plus 2. All of this, I want to combine like terms. So I'm going to have 8x squared by itself. I have positive 8x and negative 6x make positive 2x. And I have 2 plus 2 would be 4, minus 3 would be positive 1. That would be my final answer for this problem. Whew, that was a doozy. You guys did a great job. Pause the video here if you need to write any of this down. So let's just take a look at what we've done today. So we did numerical composition here in the beginning, and then we did algebraic composition here. What you might have noticed if you were paying attention with your patterns, I know my mathematicians are looking at patterns. So G and G, H and H, and then the 4 is an X. Oh, okay. So this is G of H of 4, and this is G of H of X. See here, this is F of K of -2, and this is F of K of X. So what's really cool about the composed versions, the composition, is that now you can substitute any number in to see what the composition would be. So very cool. If I want to know G of H of 4, if I already know what G of H of X is, if I know it's 5 minus 3x, right, then I can plug in the number 4 in here. So I'd have 5 minus 3 times 4, 5 minus 12 is -7. That's the same -7 as up here. It's not a coincidence. Those are the same because we in this method we plugged 4 into H and then H into G, and in this method we plugged H into G and then we plugged 4 into that composed version. Right? So super satisfying. We have two different methods that give us the same result. We could see the same thing happening over here. We'd have 8 times -2 squared, I'm plugging in here, minus plus 2 times -2 plus 1. We'd have 8 times 4, 32, minus 4 plus 1. So 33 minus 4 would be 29. The same 29 that we got up here, which is really, really awesome. So when we're composing, we have two separate methods here. We have the numerical one, which I think is probably easier. If you just have to do the number, you just have to do it one time, this is easier. If you have to do a lot of numbers into the same composed function, it might be easier to compose the functions together first and then plug in the number. So this is algebraic composition. Thanks, guys.